Today, we're doing basic maintenance on my Snapmaker U1 because ultimately I need to get tool head 3 here fixed. It's currently not feeding filament, which you can see we're missing right here. But before I call Snapmaker, they're gonna ask me to do basic maintenance. So let's knock it out. It's almost 700 hours of print time, and to be honest, I haven't done anything. So let's get started. The instructions online go right into cleaning rods, but to be honest, mine's looking a little dirty. So we're gonna start by cleaning it and then moving on to their instructions. Before we get started, I made sure I had fresh rolls of new BQ PLA so I could rule out any issues from any subpar filament. I've used their filament in this video and many other prints with fantastic results. Look for the link in the description below. It's not in the wiki, but you should always give your printer a thorough clean before actually doing anything. For example, we're starting with some compressed air to blow out the dust, filament bits, whatever else is hiding around those corners. It's better to dislodge this stuff now so we don't have to vacuum twice, clean our bed twice, or get this on our brand new grease on those rods and screws. Once you're confident all the gunk has been blown out, I just use a little shop vac to gather it all up. I've also started to have some adhesion issues, so all plates can be cleaned with a little dish soap and water, rinse, and dry it. While all PEI plates can be cleaned with isopropyl alcohol, not all cold plates can. In my experience, it's not recommended for the most grippy of cold plates, so you always need to check with your manufacturer. For example, my BQ Glacier plates in other printers can, but the extra grippy and coarse frostbite plate in my U1 here should be cleaned with only soap and water. If you need prints now, but your printer is down, head to PCBWay. They offer custom PCBs, PCB assembly, CNC machining, and for us today, 3D printing. Upload your STL. The more you order, the more you save. Then select material, color, infill, and more. Production takes a few days and shipped right to your door. Use my link in the description below to save $5 off your first order. With that cleaning complete, every month you should clean the linear rods, the carbon rods, and adjust the belts. Then every 3 months you should clean and lube the Z-axis screws and the print heads, but it's been way more than that, so we're doing it all at once. First, we're wiping down the metal linear rods with a clean, dry, lint-free microfiber rag. Because this rag will have residual grease on it, do not wipe down the carbon rods yet. Apply some lubrication or white lithium grease to those metal rods you just wiped down and move the print head fully in each axis. And repeat with only a little bit of grease going in the opposite direction. Make sure you don't get any of this grease on the XY belts, as that would make consistent movement more difficult and your print quality will probably suffer. The carbon rods get wiped down with a fresh rag and some isopropyl alcohol. These rods do not get any grease or lubrication. This is because any grease will trap little parts that get stuck in it and it'll become abrasive, so keep it clean and keep it dry. Like the metal linear rods, the Z-axis screws get wiped down, then grease or lubrication can be applied. I have my bed in its lowest position because once it's lubricated, I can home the Z-axis and the bearing will carry the grease from the bottom to the top. I did also repeat this in the top to bottom direction, using a little less grease than the first pass. Each of the print heads needs a little maintenance too. I have a little dog hair in the grease on the metal balls on each extruder, so we're going to get another clean rag, wipe down all those steel balls. We're also going to wipe the pogo pins at the top of each extruder in one direction, being super careful not to damage them. Once cleaned, we should apply some lubricant or white lithium grease on each of those balls so the print head can easily pick up and remove each extruder. Finally, it's time to adjust the XY belt. One of my belts subjectively felt a little looser than the other, so let's fix that. On the back of the print head are 2 screws that, when loosened, will automatically tension the belts. I didn't take apart this print head, but in other printers, there's typically a spring that can apply the correct tension before securing it back down. Once loosened, push the print head to each corner for about 2 laps, and then retighten those screws. That's it. Your belt is now tensioned. As far as regular maintenance is concerned, we've covered the recommendations in the wiki. However, none of this addressed my non-functioning third extruder. So next, we're going to take it apart, figure out what's going on, once again, using the wiki, because if I call Snapmaker, they'll just point me to the wiki page for extrusion issues anyway. Plus, as a millennial, I hate talking on the phone. In the Snapmaker UN Wiki, there's a section for no filament extrusion and provides this little flowchart. Again, if I'm going to reach out to support, I'm going to be sent here anyway. Step 1, well, yeah, no filament comes out of the nozzle despite filament being loaded, so we're in the right spot. Step 2 says to rotate the extruder and validate the gears viewable from the side, both spin. These are the gears that actually grab the filament and move it through the head into the nozzle. So we're going to preheat the nozzle, pop it off its mount. Once done preheating, we'll attempt to extrude the filament, and yeah, they're both spinning, but no plastic coming out. Step 3 is to remove the hot end and inspect with special attention to the heat break. You don't have to remove the extruder assembly to do this part, but it would let me see more of it, and I honestly thought the nozzle wasn't clogged. To remove it, you'd remove the large PTFE tube at the top and use a small Allen key to remove the 2 screws holding the USB cable and just give it a jiggle. Turns out, there is filament stuck in the nozzle, but even upping the temperature to 250 degrees Celsius won't soften it. I think the hardest material I used in this printer was PETG CF, which should soften at 250, but, well, this isn't no matter how much I try to clear it. While that does indeed suck, the printer came with a replacement nozzle, which was a blessing and a curse. Let me explain. The nozzle you buy off the store comes complete with a silicone sock, heat break, nozzle, heating element, and thermal goop already applied. Well, while that was on order, the printer came with just the heat break and nozzle. No heating element with thermal goop. We're going to do this the hard way. The heating element is held on with a metal clip that holds on to the extrusions by the nozzle. You'll have to use some force and finesse to remove this because it's both stubborn and fragile, thanks to the thermal grease being cooked every print. If you're lucky enough to get the metal clip off, then gently but firmly pry the heating element off. I didn't have any thermal compound handy, but with me desperately wanting to know if this was my problem, and a new set of hardened steel nozzles on the way, we're going to try it without thermal compound anyway. This is the job you need 3 hands for. One to hold the nozzle, one to hold the heating element in place, and finally another to put the clip back on. A lot of frustration off camera and on camera, but probably out of focus. The heating element is back on the smooth side with a clip over it. Put the silicone sock on, plug it back in, set the nozzle, cover it all back up, and run a test print. As you can see, we're looking good, although since there's no thermal compound, I won't be using this nozzle for any actual prints that matter. At least until I get my replacements in the mail.